In 1973, governments declared AI a complete failure and shut down the labs. This is the story of how artificial intelligence almost died.
Today, artificial intelligence answers our questions in seconds, generates complex code, and navigates busy streets. But beneath this rapid acceleration is a history of rejection. Before it powered the modern world, artificial intelligence was widely considered one of science's greatest disappointments. The concept actually began in the mid-20th century. In 1950, a mathematician named Alan Turing proposed a simple question: could a machine ever think? Turing was already a highly respected figure. During World War II, he helped Britain's codebreakers crack Germany's intricate encryption systems, saving countless lives. 6 years later, researchers gathered at Dartmouth College and officially coined the term artificial intelligence. Confidence was incredibly high. Governments, universities, and military organizations poured funding into the field, with some scientists predicting that machines would achieve human-level reasoning within a single generation. They successfully imagined the outcome, but completely misjudged the effort required. They were attempting to replicate the human mind using hardware that possessed less computing power than a modern pocket calculator. Their initial approach relied on symbolic AI, creating intelligence by writing thousands of explicit if-then rules. This rigid structure worked for mathematics, but when asked to identify a cat in a photograph, the system collapsed, unable to account for endless variations. By 1973, patience ran out. The British government commissioned the Lighthell Report, which concluded that AI research had failed to deliver on its massive promises. In response, global funding was severely slashed. Universities redirected their focus. Private investors walked away. The industry entered what became known as the first AI winter, a period where laboratories closed, careers vanished, and studying machine intelligence was viewed as a scientific dead end. The pursuit of artificial intelligence stalled entirely. The error wasn't that thinking machines were impossible to build. The error was assuming complex intelligence could be generated from a rigid list of written instructions. During this funding drought, a small group of researchers, including Geoffrey Hinton, Yann LeCun, and Yoshua Bengio, refused to move on. They continued their work in relative isolation, facing intense skepticism from their peers. Instead of strict rules, they proposed artificial neural networks, systems inspired by the human brain that learn by recognizing patterns. When the network made a mistake, a method called backpropagation sent a signal in reverse, adjusting its pathways to improve accuracy. The mathematics were sound, but in the 1980s, the hardware was entirely inadequate. Computers of the era simply lacked the processing speed required to train complex neural networks. A brilliant conceptual framework sits dormant if humanity hasn't yet constructed the machinery to run it. For decades, deep learning was trapped, waiting for the physical world to catch up. That convergence began with the internet, which generated an ocean of digital information. In 2009, computer scientist Fei-Fei Li introduced ImageNet, a massive dataset of 14 million labeled images, finally giving neural networks the real-world examples they needed to learn. At the exact same time, the video game industry inadvertently solved the hardware bottleneck. Companies like NVIDIA were building specialized chips to render realistic 3D graphics. These graphics processing units, or GPUs, performed thousands of calculations simultaneously. Researchers realized this parallel power was the exact engine deep neural networks required. These two forces, massive data and immense computing power, collided at the 2012 ImageNet Large-Scale Visual Recognition Challenge. A team led by Geoffrey Hinton introduced a deep neural network called AlexNet. This line graph charts historical AI error rates in visual recognition over several decades. You can see a slow, incremental decline until the year 2012, where AlexNet caused the error rate to plummet by more than 10 percentage points. That sudden drop proved deep learning worked. The method that experts had dismissed for decades was suddenly validated, ending the AI winter and resetting the trajectory of computer science. The global response was immediate. The world's largest technology companies rapidly expanded their research divisions, investing billions of dollars to apply deep learning to challenges far beyond image recognition.
In 2017, researchers at Google published a paper introducing a completely new architecture. They called it the Transformer, and it shifted the industry's focus directly toward mastering human language. Earlier systems processed language strictly one word at a time. Transformers could analyze entire paragraphs simultaneously, mapping out how every word related to the surrounding text to understand deep context. This architecture became the foundation for large language models. In November 2022, OpenAI released ChatGPT. Within 2 months, an estimated 100 million people were using it to write software, draft business plans, and explain complex subjects. The contrast is stark. For decades, neural network research was confined to quiet laboratories with almost zero financial backing. Now, millions of people were interacting with that exact technology every single day. Today, scientists are utilizing these systems to predict the structure of proteins, mapping biological pathways in a matter of hours that previously would have taken researchers years of manual laboratory work. But this acceleration brings complex challenges. Society now faces urgent questions regarding mass automation of labor, the proliferation of digital misinformation, and the security of autonomous systems. The speed of this progress masks how easily it could have been lost. If a few isolated scientists had simply accepted the consensus and chosen different careers during the AI winter, the modern technological landscape would look entirely different. Artificial intelligence was built by people who refused to abandon a failing idea. The machinery is finally powerful enough to fulfill the original dream of the 1950s. How we choose to direct that power is the only question left to answer.
History isn't just something we study. Sometimes we're living right through it. Subscribe to Origent for more untold stories that shaped our world.